Hello everyone, so I'm going to take us through the algebra lesson. So you're going to need to grab your algebra book nice and neatly from the bookshelf if you haven't already done so. And you're going to want to turn with me to page number 771. So page 771. So when you're ready to talk about the lesson, go ahead and press play. Okay, so now you're introducing into the wonderful world of quadratics. So quadratics are smiley face graphs that go up, and they can also go down if they're negative. Now today's essential question, what is the effect of the constant on the graph of f of x equals ax squared? Now this is a huge algebra-tique for us. So I'm sorry I'm not there, but we're gonna take it apart piece by piece so that when I come back and I'm finally able to teach, not Friday for career day, but Monday, we can take a look at that. So let's take a look at the Explorer. A function can be represented in the form f of x equals ax squared plus bx plus c is called a quadratic function. The terms a, b, and c are constants where a is not equal to 0. The greatest exponent of the variable is x equals 2. The most basic quadratic function is f of x equals x squared, which is called the parent, triple underline that, quadratic function. Okay, so what we're going to want you to do is I'm going to ask the video to be paused, and I want you to go ahead and complete this, okay? Notice that when they're plugging in -3 into the parent equation f of x equals x squared, it goes on the inside of the parentheses, and then it would be the answer 9. So I want you to finish A and then take a look at B and plot it. And then when you're ready to check it, press play. Okay, so hopefully you saw that if I plug in f of -1 and I say -1 squared, that's going to give me positive 1. So I have -3, positive 9 up here. Then I have -1, positive 1 right here. I have the vertex. This is called my vertex, the point that's at the bottommost of or topmost part. This is what we will eventually call our min and max point. It's going to be opening up. Then I would say 2 squared is going to give me 4, so 2 and 4. 1 and 1 would also be this way, and then 3 squared would give me 9. Be a nice, beautiful shaped graph. So that when I draw this all together, dun dun dun, there is my parabola, my parent graph, f of x equals x squared, okay? This is not parabola. This is pronounced in the mathematical community as parabola. Let's practice saying that like educated people. It is called the parabola. The point through which the vertex turns is called its vertex. The vertex occurs at 0, 0. It will not always be for parabolas at this point. A vertical line that passes through the vertex, divides it, is what we call our axis of symmetry. So if I come on over and I draw an axis of symmetry right here, okay, notice the axis of symmetry is always y equals 0. Or I'm sorry, x equals 0 here. Okay, for this function, the axis of symmetry is our y-axis where x equals 0. Okay, that would be essentially drawing a line like this, a dotted line. Okay, let's turn the page. So before we do though, make sure you know that the domain and range of these are always going to be the set of all real numbers. I'm going to write the word numbers, and that the range is always going to be y is greater than or equal to 0. Okay. Now we're going to talk about all the different kinds of parabolas. Okay, we're going to talk about super stretch, which means it's going to get super pulled this way. We're going to talk about compression, which is more bowl-shaped, going side to side. And it all depends magically on whatever A is doing. So explain 1 on page 772 says graphing g of x, which equals ax squared when a is greater than 0. So it says this graph is a vertical stretch or compression of its parent function, f of x equals x squared. The graph opens upward where a equals 0. Now I love your book, but it should have showed you that if I pick a number bigger than 1, what happened to the shape of the graph? The graph grew to be narrower, which makes sense, right? Because you're talking about something like f of x equals x squared, our parent function. If we throw a number in there and we say that's 4x squared, that's going to make this a lot more narrow. But if I pick a fractional value that's between 0 and 1, it is called vertical compression because the distance between a and x squared becomes wider. So if I compare that, f of x equals x squared, and then I go ahead and I use a fraction, like let's say 1/5, just throw that in there. So I have a new function like g of x equals 1/5 x squared. Notice that the shape becomes more bowl-like, so we refer to that as vertical compression. Now both of these graphs right here at the vertex is called our minimum because this is what we call the lowest point on that quadratic parabola. The domain will always be all real numbers. When a is greater than 0, the graph of g of x equals a times x squared opens up and has a minimum value that occurs at the vertex of the parabola. So the range is always going to be a is greater than 0 as long as a is greater than 1 or a is between 0 and 1. That's the only time that part is going to be true, okay? So here's, I love the book right here. So it's going to have you give you an example, graph each quadratic function by plotting the points and sketching the curve. State the domain and range. I also want you to label where's your min or max, where's your minimum value, and where is your axis of symmetry, just to get in that vocabulary practice of identifying where the graph splits to be the same. And then when you're ready, press play. So I'm going to ask the sub to pause the video and give you guys a chance to look at A and B. Don't forget to do the domain and range and answer the reflect question. So you're looking at A, B, and number 3 on page 772 to 773. Okay, so if I take a look at the graph, I know that I could come on over and I could use Desmos. So let's just, we went all over Desmos real quick. So I could say that my function is going to be y equals x squared. So I'm going to say y equals x squared. I'm going to zoom this out a little bit, make sure it's actually to the second power. There it is, beautiful bowl-shaped graph. Now watch what happens if I just type a number. Y equals 2x squared. Ooh, look how high up that is. Y equals, let's make this 12x squared. Look at how much that's vertically stretched. Tighter and tighter, tighter, closer and closer and closer to the y-axis, okay? All right, so if I come back to this one, the book did this for me, but I wanted you to label this is your minimum. Your AOS is kind of how we symbolize axis of symmetry, is going to be the y-axis, or where x equals 0. Okay, it's going to look like this if we actually drew it out. That will come into play later. The domain is all real numbers, and the range is y is greater than or equal to 0. Okay, let's look at the fun stuff. What if we made the graph lighter? What would happen? So I know that if I plug in 0, I get out 0. So I'm going to want to do that. Then it wants you to plug in -3 for x, so 1/2 times -3 squared, and that's going to give me 4.5. So -3, 4.5 is going to be right about here. Then I would say 1/2 times -2 squared, and that's going to give me 2. -2, 2. And then because it's a balanced quadratic, it'll be the same on both sides. So let's draw a beautiful bowl-shaped picture like that. If I could draw beautiful like Miss May, I would see that these are the same thing. And it's having you compare that to your usual graph, which looks like this. I'm going to go over that in a different color. My yellow graph is my parent function. All right, so what happened to the graph? It got vertically compressed. Yes, I want you, even if I'm not there, to write the words vertically compressed. Okay? You need to make sure that you're seeing it's becoming wider is the non-algebraic word for that. Compressed is how we say it. The domain is still going to be all real numbers, like we've talked about. That's not a hashtag, that's a number sign. And then the range is going to be y is greater than or equal to 0. So for a graph that has a vertical compression or stretch, such a good STAR question, does the axis of symmetry change? And the answer is Never until the end of time will it. It will not change. It will have the same domain and range. The axis of symmetry will always be at the middle, okay, at this point. So the answer is no. Okay, I want you to try it one more time. Don't give me the look. I want you to graph these two equations. I want you to tell me the domain and range. And then we're going to talk about what happens when we give the graph a negative number. Okay, so I'm going to have the sub pause the video, and then we're going to take a look. Okay, so if I look at 3x squared, I can see I should have had 0, 0. I can see I should have had 2, 3, negative 1, 3, positive 1, 3. I can see it's a vertical stretch. Hopefully we wrote that because it's a vertical stretch up. I can see the domain is all real numbers. I can also see that the range is going to be y is greater than or equal to 0. Then I'm going to do the same thing for 1/3 x squared. Your domain is going to be all real numbers. And then your range is going to be y is greater than or equal to 0. Notice this is going to be a vertical compression because it's more bowl-shaped here. So I'm going to have 0, 0. I'm going to go out like this. I'm going to keep going out like this. And I can see it's just getting really, really compressed, really wide because the distance between the top and bottom of the fraction is going to be small. Okay, now I get to go into the frowny face-shaped graphs. That's what we call when a is greater than, or sorry, not greater than, when a is less than 0. We have sad face graphs. The graph of y equals negative x squared opens downward. It is a reflection of the graph y equals x squared. So when a is less than 0, the graph opens downward. And now instead of a min value, it has a max value. Okay? Still vertical stretch applies. All the negative is doing right here, if it's flipping downward like this, is it's just reflecting that graph. It's just flipping it upside down. Okay? So it says the graph is narrower, so same rules apply. The compression is also going to be wider. The only thing that's different is it just has a negative sign. So I could say g of x equals negative 1/3 x squared. All the negative did was just flip it upside down. This is still a compression because it's wider than the original. This is still a stretch up because it's tighter than where we started. Okay? Okay. Let's take a look at 774. So it says graph each quadratic function by plotting points and sketching the curve. State the domain and range. So I want you to take a look at A. It's done for you. What's your domain and range? I also want you to label where the max is and the axis of symmetry, like we've been talking about, where you could split it in half. Take a look at B. What's your graph? What's your domain and what's your range? And then I love this one. Does reflecting the parabola across the x-axis A is less than 0 change the axis of symmetry? Okay? Okay. So I'm going to ask the sub to pause the video at this point, and then we're going to take a look at what you guys have. Okay. So I know that my parent graph is always f of x equals x squared. Okay. I know that this is actually, the domain is going to be all real numbers. But because I have a maximum right here at 0, 0, that means my range isn't going to be greater than or equal to 0. It's going to be less than or equal to 0. It's also a vertical stretch. Why is it a vertical stretch? Because if you go back up to the other page, it says the absolute value of A is greater than 1. So if I take the absolute value of negative 2, guess what that's going to give me? 2. It's still a vertical stretch. Okay, now hopefully you saw that even though this is negative, okay, when I graph all these things and I'd say negative 1/2 times negative 3 squared, I get negative 4.5. Here, if I plug in negative 2, I got negative 2, and then I got negative 1/2. You can see it kind of just snakes around the same way, 0, 0, negative 1/2, and then 2 and negative 2. There you go, 2, negative 2. Okay. Making sure I had it, 3 and negative 4.5. Negative 4.5 here. Let me fix that so it's right at 3 and 4.5. Okay, now I can see I have this beautifully vertically compressed graph flipped downward because it's more bow-like, right? Like we said, this is considered to be our max point. Our domain is all real numbers. The range is y is less than or equal to 0. Okay? Does reflecting the parabola across the x-axis a less than 0 change the axis of symmetry? The answer is no, it does not. Okay, now you're like, Ms. Trail, this isn't hard. This is not bad. I'm starting to see patterns. Okay, forgive me. This is going to get a little bit hairy. Now we're going to turn in your books to explain 3, which is on page 775. And there might be a little bit of a math challenge to end today. It's going to be a little bit more complicated. Okay, you can determine the function rule for a parabola by substituting x and y values for any other point into g of x equals ax squared and solving for a. Dun, dun, dun. So notice the function for a quadratic function. Start with functional form. G of x equals ax squared. It's g of x because we're not starting with the parent function. They want us to go through the point 2, 2. So just like this point has an x and a y value, I have to substitute in my x is 2 and my y is 2 there. Then I have to work backwards and say 2 squared is 4, divide both sides by 4, and I get 1/2. Now, works the same way with negatives. Don't worry about it. So I'm going to come over, and it says use the point -2, -8. So I'm going to replace x and y, that's my x, that's my y, with a -8 for g of x, -2 for x, and if I say -2 to the second power, that's 4. Then to get rid of the 4, I divide both sides by 4, and I get -2 equals a. So that means my answer would be g of x equals -2 x squared. So that would be my function rule. Okay, I'm going to ask Mr. Peters to pause the video, and I want to see if you can do the same thing for the function rule for both 9 and 10. And then when you're ready, press play. All right, pause the video now. Okay, so let's take a look. I have to write g of x equals ax squared, like we talked about. I need to make sure this is my x and my y coordinate. So then I have to say 4 equals a times 1 to the second power, because that's my x coordinate. Thankfully for us, I don't have to do much. Divide both sides by 1. So a gives me 4. So my equation is going to be g of x equals 4x squared. Boom, I got it, not a problem. Same idea for 10. So for 10, I'm going to say f of x equals ax squared. Then I need to use this point, plug it in for x and y. So -1 equals a times 1 squared, divide both sides by 1. So a is going to give me -1. So my equation is going to be f of x equals -1 times x squared. Okay, the last part of today's lesson is we have to talk about cute little dolphins. Behold the cute dolphin face. It's so great. So great. So it says real-world situations can be modeled by parabolas. For each model, describe the vertex, y-intercept, and endpoints that represent the situation it models and determine the equation of the function. Behold the cute dolphin. Smiley faces. This dolphin models the depth in yards below the water surface of a dolphin before and after it rises to take a breath and descend again. The y-intercept occurs at the vertex of the parabola at 0, 0, where the dolphin is at the surface to breathe. That's its max point. The endpoint, -4, -32, represents a depth of 32 yards below the surface at 4 seconds before it reaches the surface to breathe. The graph is symmetric about the y-axis, like we talked about. That's where it splits in half. Same thing on both sides. So then it wants you to use a point on this parabola to find your equation for the cute little dolphin breath. And so they just picked the point for negative 32. So they substitute that in place of x and y like we did, and they get negative 2 squared. Negative 2t squared. Okay, I want you to take a look at the rock problem. So I want you to take a look at number 11 on the next page, and I'm going to ask the substitute to pause the video on page 777, and I want you to write your function, talk about your axis of symmetry if you see it, what your min and max point is, okay? So you're going to write the function of the time in t seconds. So press pause now. Okay, so I'm going to write f of x equals a times x squared. I'm going to use the point 2, negative 64. So I'm going to come down and plug in negative 64 for y. I don't know what a is. And I'm going to say times 2 squared. 2 to the second power is 4, so I have to divide both sides by 4. And I'm left with negative 64 divided by 4, which is negative 16. So then to find my equation, I'm just going to make a pretty little equation. F of t, because it says t in seconds, is equal to negative 16 times t squared, because I'm talking about quadratics. Now remember that before you put your books nice and neatly back up, let's take a look at your homework for tonight. It is going to end up being HRW. Don't hate the message. It's going to be okay. But I do need to make sure that you're doing your HRW and turning it in, because Friday is career day. I do have tutorials Friday morning if you need to come catch up. Thank you, Mr. Peters, for all your hard work, and I will see you guys back tomorrow.